our senior 1.2 homework. This is due on Sunday. Let's go ahead and do a few of the problems together. I want to do at least one from each section so you can kind of follow along. So I want to first do number 4. Now let's look at the instructions for this. What I want to see on this entire assignment is, what do you notice on the graph? And then what does the algebra tell you? Okay, so we need to kind of think of both of those things simultaneously. So here it says to use the graph to estimate the indicated function value. So that's where we're going to do it on the graph, and then confirm it algebraically, rounding to the nearest 100th if necessary. Okay, so I have taken number 4 and I've copied and pasted it here, and so let's go ahead and do number 4, and let's follow those instructions. So you're going to show me where is p of -6. Now please watch the way that this particular book uses their graphs. The x and y might not be counting the same. Please always check it. If we look at our x-axis, it's counting by 2's. If it's on the y-axis, it's also counting by 2's. Don't always rely on that, so please always check that, okay? Now, if as I'm going through this, if you have any questions, please use the chat feature, and then I'm going to also ask you just some questions in general. So if we look at p of -6, that is going to be this point right here on the graph. So from the graph, it appears that that is the point -6, -2. Okay, so tell me what the graph says. Now we're going to check the algebra. So the algebra of p of -6, since -6 is a value less than 2, we're going to use that first piece, and we always get -3. And guess what? The graph did say -3. I'm sorry about that. I told you it was counting by 2's, and I didn't listen to myself. I'm sorry. Both the graph and the algebra say that at -6, we are at -3. Okay. Now I would like to do B here, p of 2. So let's go to the graph and find p of 2. And maybe color it in on your graph. And so the graph says that that is the point 2, 1. Okay. Now let's do the algebra. So the algebra part of things, if you look, since our value fits this category, we're going to use that function to find our value. So p of 2 is going to be 2 take away 1, or also 1. Okay? So what you're just kind of doing here is practicing blending the graph and the algebra together. Now let's do the last one. P of 9. Since 9, well, first let's do the graph. So p of 9 looks like it's right here. So the graph, it looks like that's the point 9, 8. Now let's do the algebra. P of 9 is going to be 9 take away 1. Since our input value is bigger than 2, we have to use that bottom function. So it's just going to be 9 take away 1. Or it is actually 8. That's it, okay? So you're going to find me the point on the graph, list what that point is, and then I want you to show the algebra. Even, you'll notice, I can do that in my head. You know, like look what's in purple. I can do 2 minus 1 in my head, but show me that. Show me that you can see, you know, I can clearly see what algebra was used. Are there any questions about the first sections of this homework? Just if you have any questions, type it in the chat, okay? So it appears, you know, for these, I want 2 things. Show me what the graph is saying and show me what the algebra is saying. So that is the instructions for the first part. Now we're going to do this part. Now this is about domain and range, I'm going to do with you right now problem 12 and problem 14. So it just says to use the graph to determine the domain and range. Now what I'm going to do is I'm going to use interval notation. I want you to use interval notation as well. So let's look at 12. So remember, domain and range is all about what x's show up on the graph from left to right, what y's show up on the graph from bottom to top. So first let's talk about the domain. So if I've got a little math bug here, and he started out way to the left, as far as he could go, he could have started at negative infinity, okay? So think about, because of that arrow that he's sitting on, he could have started to the left, as far left as he wanted, and we designate that with negative infinity. Now think about if he kept walking. What is the first point? Could you type in, guys, type in the chat bar, what is the first x value he gets to where there is a problem? What is the first x value he gets to that there is a problem? Anybody else have an opinion? Well, Tara and Kyla, you got it. Sarah, our 7 actually is going to come up here in just a little bit. So I like your 7. We're going to get back to that. But 4 is the very first thing he comes to where there might be an issue. Now, Sarah, I like it that you said 7 because technically, look, there is a spot that he can stand at an x value of 4. So you could go, I have 4 missing, but I saw 4 again. I don't like that as much as saying, okay, I got to 4, I had an issue, but I found 4. And so I found 4 somewhere else. Now, let's say he's jumped down to here. And now, Sarah, next comes your 7. You noticed that 7 is where he has to stop. Sarah, can he stand at 7? Yeah, so since he can stand at 7, we know that we can include it in a bracket. So this is the answer I want. The first answer is totally acceptable. It is correct. See how 4 is included right there. It's just a little more efficient to say, okay, he can jump down to the other 4 and then keep going. Okay, so that's our domain. Let me erase all this. And let's talk now about our range. Now the range is the bottom of the graph, all the heights or y values that are used to the top of the graph. So guys, type in the bar here, in the chat bar, what is the lowest y value that he can hit? What is the lowest y value that he can hit? You guys got it. Perfect. So he can stand at -1. So let's assume for a minute our little math bug has made his way. He's standing down there at -1. That is a singular y value. He can't get to -1.5. He can't get to -0.5. He's stuck at -1. Now this is the way to write it. You just say the -1 is included. I've also seen it written like this. I start at -1 and I stop at -1. Either are acceptable. I go the lazy route that I only have to write it once. Okay, now let's think about the next place he's going to jump to. So the math bug is going to jump up now to this y value. Now, can he stand at the next y value? Give me a yes or no. Can he stand at the next y value? No. So the next y value is, I think to my head, well, if that x or y value of 1 was filled in, he could stand there. But now he's stuck. there's a hole there, and he doesn't want to fall in the hole. So how do we write that? Well, we say the next y value we could get to is 1, and you put it in a parenthesis to mean, well, he can almost get to 1, but not quite. Now let's think for a moment for our little math bug here. He can keep going up for the rest of his life and keep going up now to infinity. Okay, so that is the range for that. Takes a little bit a different way of thinking about it. So domain, think as he walks from left to right, what x values does he use? Range, think about from bottom to top, what y values does he use? I want to try 14 now. Okay, so everybody tell me well, let's draw my little math book here. So he could start at an x value of negative infinity. And most people kind of recognize that. Now you guys type in the bar, what is the first x value where things are going to go wrong? He might fall in a hole. He might have some kind of problem that he has to jump to the next spot. What is the first x value where he has a problem? Type it in the chat bar. So I see lots of -5s, and that's perfect. -5 is our x value where he is going to come across a hole. Now he doesn't want to fall in the hole, and so because of that, he can get to just before -5, and we write that with a parenthesis. Now, he is allowed to jump over the hole and keep going this way. He's kind of going backward here, but you know what I mean. He can keep going this way, okay? So once he starts walking that way, the way that we designate that, and I'm sorry I wrote it so big, is he can go from the other side of -5, and that's how we would write the right side of -5. Now he's going to keep going, and he's going to keep walking. What is the next x value he's going to get to that he has a problem? What is the next? Type that for me in the bar. What's the next x value he's going to get to that he has a problem? Perfect, guys. You guys are really seeing this. This is wonderful. The next value he's going to get to is an x value of 3. At the x value of 3, he must stop. Now, can he stand at 3? Give me a yes or no. Can he stand at 3? Give me a yes or no. Can he stand at the 3 value? Yes, he sure can. And so we designate that with a bracket on the 3. That tells me that, hey, he's allowed to stand there. Okay. Now let's talk about range. Now range is how low can the bug go to how high can the bug go. Now let's assume that the bug has wings. He can jump from section to section to section, okay? Can you guys type for me, what is the lowest y value that this bug can stand on, can get to? So he is flying around and he wants to find the lowest point that he can get to. Where is it? Okay. Yes, it's a y value of -5. And he can stand there, right? So it's closed in with a -5. So that's our y value. So now he wants to fly as high as he can get. Now let's think of, he was down here at -5. He can go up here. Is there a spot he could jump to go even higher than that? So everybody kind of write something. Where could he jump to go even higher than that? So right now he's gotten as far as 0. Yes, the arrow, the infinity, perfect. He could go over here. It doesn't matter if he just leaps over to it because remember our domain or our y values might repeat themselves, and so he can keep going up to infinity. Okay, so that is number 14. So I just wanted you to see some of the domain and range ones. Does anybody have any questions about those? They do take practice, so again, you really want to jump in there and give this homework a good try. Okay. Now I would like to do number 17, let's read the instructions for this section. It says use the graph of the functions to find the y-intercept and zeros, and then find these values algebraically. So I did 17. I cut and pasted 17 here, and so we're going to look at the y-intercepts and zeros. Now, the equation for this was cut off a little bit. It should read 3x, okay? So let's take a look now at 17. Let's start with our zeros. Now the zeros, let's do that in a different color. The zeros are a fancy term for the x-intercepts. The x-intercepts are where this graph touches the x-axis. So graphically, it looks like I have 3 x values where that happens. An x value of -1, an x value of 0, and an x value of 1.5. Now that's what the graph is appearing as, okay? Now, they said to show algebraically if that's the case. So zeros are the harder to find. The zeros occur, you're going to set the function equal to 0. So I'm going to write out the function and set it equal to 0. Now sometimes they're just going to be standard equations to solve. Sometimes, like this one, they're going to require that we use some factoring. So let me remind you how to factor. The first thing you want to look for, is there any greatest common factor? Can you guys tell me, is there anything that each one of these terms has in common? You got it. Exactly. So remember, you can factor out that x. Anytime they have a common factor, that's the easiest way to kind of instantly simplify it to get you started. And so we get this. So all I have done is removed, factored out, divided out an x. Now, I want to see, hopefully, if this thing can be factored. If it can't be factored, you may have to use the quadratic formula, depending on, if you really suck at factoring. I'm going to take this to the side over here. I'm going to do something called slide and divide, which I might have already done with you, but just humor me here. To factor this, if you aren't good at factoring, a method I really, really like is called slide and divide. If there's a front number, you slide it over. You pretend like I'm factoring x squared minus x minus 6, because that makes a little more sense to our brains. And so that would be x minus 3 and x plus 2. I slid over a 2, so it's called slide and divide because now I'm going to divide off the 2. If the thing isn't divisible by 2, just stick it on the x. If it is divisible by 2, divide it. And so I found the factors. Once I've found the factors, I set each factor equal to 0 and solve it. So that one's solved. Don't forget that front one. It is a 0. It is a legit answer. And this one's just an easy one. And look at what we got. We got 3 answers. They match exactly what the graph told us. Okay. Now we need to do the y-intercept. So let's look at what the graph says. The graph, if you go back up here, this is the only place that this graph touches the y-axis. That's our y-intercept. Now you can put it like that, or you can put the point. It doesn't matter, whatever floats your boat. And then how do we do that one? Well, this is much easier. You just stick in 0. And so our equation was 2x cubed minus x squared minus 3. So it's going to be 2 times 0 cubed minus 0 squared minus 3 times 0, which is 0. So see how the graph and the algebra is going to work. So to find your x-intercepts, you're going to set the function equal to 0, usually factor it or solve it. For y-intercepts, you just get to plug in 0 and you're going to get one particular value. Any questions on the x or y-intercepts for the graph? Okay, we're almost done. I know this is a long one, but we got a lot of good stuff to talk about today. Okay, so in this section, near the end of your Ed puzzle, I talked about symmetry. Okay, to see on the top, I have highlighted y-axis and origin. The only ones I want you to confirm algebraically to show me the algebra for are those two. Okay, x-axis you can say yes or no based on the graph, but I don't care about algebra for that. Those don't happen unless it's not a function, and I only want to care about the symmetry of a function, which are the ones I've highlighted. So again, please only do the y-axis and origin algebra part of things. So I have highlighted number 28. So if you want to do 28 with me, we're going to talk about the symmetry of the functions. So we have three symmetries. The x-axis, you're only going to look at the graph. The y-axis, we're going to do the graph and the algebra. And that's going to occur for what's considered an even function. And the way that we check it is we plug in negative x, and it should go right back to the way that it looked originally before you plugged in negative x. So you're going to do that one. And then we're going to do origin symmetry. The way that I think of origin symmetry is I think of it as like if you put a push pin in the middle and can flip it around 180 degrees and it doesn't change, kind of like a pinwheel. Think of a pinwheel and that will help you. Those are odd functions. The way that you check it algebraically is we're going to plug in negative x, and if it just looks exactly like I just multiplied the equation by -1, you know it has origin symmetry. That's the algebra we're going to search for. So 28. Give me an answer here. Can we fold that over the x-axis and get a perfect mirror on the other side? Can we fold that over? Does it have x-axis symmetry? Give me a yes or a no. What do you think? Does it have x-axis symmetry? It does not. You're right. We can't fold it over and match it up perfectly. Now, can we fold it over the y-axis? No, we can't. Does it appear we could put a push pin in the center and rotate it and still get what we should get? Yes. So it appears from the graph, just say what it is from the graph. It looks like origin. Now, how do we check it algebraically? Well, we're going to take our equation. I'm going to write it in function version, function notation, and I'm going to plug in negative x. And it better appears if I just multiply by -1 when I'm all done. Now watch what happens. Negative x cubed over 4. 3 negatives are going to stay a negative. Wouldn't you agree that this looks like I multiplied the original by -1? When that happens, and that is a 3, when that happens, yes, it is an odd function with origin symmetry. Okay, so it's just, I call it the negative x test is your algebra. You're only checking the algebra if it's y-axis or origin. If it ends up being just x-axis, just say x-axis from the graph and be done with it. There's nothing I want you to check algebraically for that one. Okay. So that is the symmetry section. Does anybody have any questions about that? Okay, so that's everything new. I do want to do 55 with you before we finish here, just because it's a piecewise function, and I showed you 2 of these just so that you could practice. Domain and range can be a little tricky when looking at a graph, so I just want to do one more with you, and then we'll call it a day. Okay, 55. Find the domain and range. Think of our math bug. X's are counted by 2's and so are y's. He cannot stand at -8, and that's not an 8. I'm sorry. He can't stand at -8, and he has to stop at -4. Now, the next x value that almost appears is -2. And then he can walk to 4 and stand there. And there is a spot right here that he can get to 4.1, 4.2, forever he can keep going. And so because of that, he can keep going to infinity. Now if you put 4 in a bracket and then started again with 4 in a parenthesis and went to infinity, it is the same answer. I like to try to write as little as possible. So there's your domain. Let's talk about range. Bottom to top. The lowest this bug can actually get to is almost, but not quite, -6. We write that with a parenthesis. Now, if he just stays on this piece and ignores every other piece, he can keep walking forever, up and up and up and up and up. These pieces are in there, but all I care about is how far can I go, and do I have to skip any y's? I don't. I can just stay on this piece, and I can get to infinity. So that is the end point for our range. Does anybody have any questions about 55? Does anybody have any questions about the homework in general? So we are going to meet again virtually tomorrow. Tomorrow, between now and tomorrow, start a few more problems. So that tomorrow I'm going to answer any questions that you have about the ones I haven't done, so that you can continue and work on these that are due Sunday by noon. Okay, any questions before we go? Okay, guys. Well, thank you so much for being here, and we'll talk about more of these in the future.